Hello, everyone. So, myself, Aditya Singh. I'm the founding member and head of business and infra at BosonQ. So, let's start about what we are. BosonQ is an enterprise SaaS startup that uses quantum algorithms to accelerate complex simulations for automobile and aerospace industries. We are headquartered in New York, based out in US, UK, and India. And we have raised around 1.1 million from investors backed by VCs. So what we are actually solving. So currently, if you see the simulation market, all these industries that you see are using these particular simulation softwares that can actually solve only 30% of the simulation. Because the other 70% simulation that you see cannot be solved because these softwares are not capable of doing such complex, and it's expensive for them as well. We at BosonQ are developing BQ5, which will unlock the 70% of the simulations that are not possible here. How we are doing this? The way possible we are doing this is by integrating quantum algorithms with the simulation solvers, which will make these simulations simpler, easier, faster, and more accurate. So if you see this slide, currently, the current simulation softwares that run on supercomputers are slow, are low accuracy rates, performs fewer iterations. But with BQ5, which leverages quantum algorithms, you can use, we can see a magnitude of 1. And when the quantum computers are much mature, in a later 2 to 3 years of stage, we can see a magnitude of 2 to 3 degrees faster of simulations. So I'll show you this by an example. We did a use case with Maruti, and we did a POC with Maruti on control arm, where it was shown in the image here. The objective was to reduce the weight. We used BQ5, and we compared our results with current simulation software. And what we achieved was 7% lighter weight of the control arm, and we used 1/8 of the HPC resources. That resulted in $500K of material saving, along with $29K of HPC cost. So this is just one of the components that we see in a car. There are thousands of such components. And one of the components that we are chasing right now or solving is weight reduction in chassis. With the numbers that we have seen in the previous slide, we are extrapolating this number, and we can save around, with BQ5, 1.2 billion in material and 50 million in just SPC cost saving. Another very important use case that most of the automotive industry is dealing with is battery weight reduction because of thermal runaway. And we have seen using BQ5, we have increased the range 8%. So this is what impact BQ5 is creating at this point of time. So currently, we are on our first quantum-inspired algorithm. The alpha of our product is out in the market and is used by super users and our super user companies as well, and it delivers design optimization. But keeping in our mind, the R&D team of ours is also working in partial differential equation, because this is one of the most important simulations that needs to be solved. And this is why we are using quantum computers, and this is why BQ5 is made. So currently, if you see BQ5 is a horizontal cross-selling product. So we are focusing on mobility sector that primarily focuses on aerospace, manufacturing, automotive for next 2 to 3 years. But this design optimization, once out in the market at the end of this year, can be used by any industries: energy, pharma, electronics. So it's not a one-stop solution for one market, but can be used by any market. So currently, there are different channel sales that we do. One of the leading channel sales are direct sales, which particularly I lead. A lot of the heavy lifting is done by us. With all the customers that we have currently is done by the heavy lifting sites in-house. But we have other simulation companies, Ansys, SimScale. So there may be a question, why these companies? As I said, our solution can be integrated with the current simulation softwares as well. So for the customers, it is easier to use. Is it easier to use? and they do not have to change their infrastructure as well. So they are one of our channel partners, along with high computing, performance computing networks like AWS, Microsoft, system integrators like Tata Consultancy Services, Tech Mahindra, Capgemini, and quantum companies like Strangeworks and IBM Quantum. So our enterprise, what is our business model? So our business model comes as a pay-per-use model, which we use is based upon base plus consumption, and it's of a very high ticket size. Most of our expenses right now are going into growth expenses, 40%, which is on sales and marketing. Rest of the 60% goes to the product development and R&D expenses. If we run at this growth, when the product is out in the market, we can be profitable by in less than 2 years. So achievements that we have done in last 3 years of our journey. Right now, we are part of an Alchemist Accelerator and a Hustle Accelerator as well, a US-based Army Accelerator that we are part of. Recently, we are the only Indian company that became a part of IBM Quantum Network. And we have been in the headlines for different news on the EV industry, on the quantum side that we are doing, and we have been invited to many keynote speaker sessions as well. Now comes the team. So our team, with along my 3 other co-founders, my 2 tech co-founders are based out of US and are PhD in this respective area of simulations. They have worked with NASA, Open Lab New York. These are some of their expertise. They have been into the industry for a longer time, and this is the reason we are targeting the industries. Along with that, we have 23 other members, which are led by another industry experts, like likes of Vijay Sethi, ex-CIO of Hero MotoCorp, John Sirani, ex-co-founder of Past and Whitney, and this is how our team is made of. Thank you.
Thanks, Aditya. Great presentation there. So we'll move into the Q&A portion of the pitch here. Judges, any questions? Let's go with them first.
Thanks for the great presentation. Question regarding your business model. How many customers do you have right now, and how do you envision the next couple of years, and how do you see the business model evolving?
Yeah. So with the alpha product out in the market, we have 3 customers online that we are working with on POCs and pilots. So the customer base that we are working is through POC and pilots until the product is out in the market. Once the product is out in the market, we have already a pipeline of 48 customers who are ready to use the product. But before getting into the market, the only thing we are making sure the customers that are adaptive to the newer technologies and those who want to see results are 2 types of customers. With dealing with quantum, customers are not very excited about what is quantum, and there's a lot of myth going around it. So we deal with customers who are very much interested, know about the technology. They want to use it. Once we get their review or testimonies that, okay, this is something that we want to use and this is showing some results. That is why we have developed POCs, pilots, we are working with them, and then they become the users of beta, and then they become the final product users. So list of 5-10 customers that we want to target right now, with 3 already we are signing the contracts, and 7 left in the market we are talking to on signing contract side, advanced stages. We see a lot of attraction once the product is out in the market. But the first need is the customer seeing out it.
Next question, please.
Thank you for your presentation. And can you tell us more about the competitive advantage of your quantum algorithm to classical algorithm? What kind of problems will suit for your quantum algorithm? So
quantum algorithms is something, a near future that we see. Quantum computers coming late, maybe mature in next 5 years or 10 years, we don't know. But something that we want to show it now can be done to quantum algorithms. Quantum algorithms show advantage of 10x to 20x depending upon the complexity of the use case. So if the use case is much more bigger, you'll see much more difference. If the use case is much more smaller, the difference might be smaller. But yet there is a significant difference between quantum algorithms that run on HPCs or supercomputers rather than classical ones.